So this is one problem in zeroth law of thermodynamics. That is, there are the various temperature scales are there. What are the temperature scale? That is constant volume gas thermometer is there, constant pressure gas thermometer, resistance thermometer. Next one is a thermocouple is there, digital thermometer is there. So like that one, the different Wheatstone's bridge resistance thermometer. So there are the different varieties of thermometers are there. And here there are certain relation, that is T degree F is equal to, so the relations T degree F is equal to 1.8 T degree centigrade plus 32. When T degree centigrade is 21, then what is the value of T degree Fahrenheit and what is the value of these relations? So these relations at T degree centigrade 21, apply that one, you will get the values as this one. Just only for showing the relation purposes. When T degree centigrade is equal to minus 40, substituting that in this particular T degree F and T degree R, then values you will get like this. If T degree centigrade is 500, substituting that in Fahrenheit and Rankine scale, then you will get like this one. In T degree, if T degree centigrade is equal to 0 degree centigrade, then what about the Fahrenheit and what about the Rankine scale? So this is how the relations are there. In the same way, the T degree centigrade with respect to the Fahrenheit is given over here. When the degree Fahrenheit value is 68, then what about the degree centigrade value and what about the absolute Kelvin value? So there are the different situations are there. So try to go through that particular problem. Try to go through that particular side so that you can get the knowledge onto this particular side. Next. So there is one more problem here. This is a thinking level question. This is a thinking level question. What is that particular question? Here it is shown that, so as shown in figure, that is, this is the figure, and here there is a pipe, a small diameter water pipe, small diameter. So a small diameter water pipe passes through 6 inches thick exterior wall. So this is the wall is there. So in that wall, a 6 inches diameter pipe is passing through the wall. If the temperature varies linearly with the position, so if the temperature varies linearly with the position x through the wall from 20 degrees centigrade, so at the left hand side it is 20 degrees centigrade and the right hand side it is a minus 6 degrees centigrade. In between that one there is a pipe which is passing through the wall at a distance of 3 inches. The total length of the wall is 6 inches. Out of that one, central portion is through the central portion the pipe is passing, and would the water in the pipe gets freeze? Why? Here the value is given as a 20 degree centigrade and at the outside the value is given as a minus 6 degrees centigrade. Now I have a doubt whether this particular water is going to be frozen or whether this particular water is going to be clogged into this particular pipe. So this is what you need to solve. Sometimes the problems are in a realistic situation, especially for the thermodynamics point of view. So how you are going to solve this particular case? Then here it is mentioned if the temperature varies linearly with the position x. So that temperature where in this particular case you can take it as a mx plus b or mx plus c. So this where m is nothing but equal to the slope. So that slope is nothing but the change in temperature divided by the length. So what is that change in temperature? It is minus 6 degrees centigrade minus 20 divided by 6 inches. So you will get the slope. Now at the left hand face, so at the left hand face, that is here temperature is 20 degrees centigrade, and now you will get the m value, but x is equal to 0. So at the left face, x is equal to 0, and in that case the temperature is 20 degrees centigrade is equal to, where x is 0, that means this is 0 plus b. So you will get the value of b in this particular case. then what you have to calculate? You have to calculate this case, that is whether the water is going to be gets frozen or not. So that is the T is equal to, you will get the slope from this particular case. So minus 26 divided by 6. So more or less you will get it as something 4.5. So that the slope is 4.5. So this slope is, minus 4.5. So minus 4.5. X is 3 inches because this one 3 inches plus and this value. So it is 20. So you will get it as around the temperature. If the value is in between this minus 6 and 20, then water, danger of water frozen, danger of water gets frozen. So that particular things you can find out from this particular type of a problem. So it is a the thinking level question. Sometimes you will experience from this particular types of a problem. So this is one model type, that is the T is equal, the thing is that T is equal to mx plus c, that is the linear relation. The water passes through the 6 inches thick exterior wall of a dwelling if the temperature varies linearly with the position x. So that you should, that thing, it is to be strike in your mind. T is equal to mx plus b. So if you substitute that case, then you will get that particular case. So hope, I think this is once again the problem is repeated, the same variety. So you can also go through, but here with different numericals, different numericals. So in the previous classes, we have also discussed the understanding level questions. That is, already we know that the intensive properties and extensive properties. So in this particular case, if you just observe that whether it is a property or not, because we have covered the intensive property and extensive property. So integral of PdV, whether it is a property or not. Integral of VdP, whether it is a property or not. What about this case? So integral of PdV, because the P is a function of V, and the integral can only be evaluated if the relation between P and V is known. So it is thus an inexact differential, because PdV work is nothing but it is an inexact differential work, and hence it is not a property. So that's why work and heat are not the property of a system. Work and heat are not the property of a system. Next, there is a VdP. So it is also not the property for the same reason, because here V is a function of P and the relation. The third equation, that is PdV plus VdP. What about this one? So integral of PdV plus integral of VdP, that you can write it as integral of PdV plus VdP. So that is integral of differentiation of PV. So you will get this particular relation. So finally it is nothing but equal to PV work. So thus the integral can be evaluated without knowing the relation between P and V. So it is an exact differential, and hence it is the property of a system, and hence it is the property of a system. So this is how you can make the calculation. And there is one more derivation. Sometimes you can also get the derivation like this case. So here you have to prove this relation. T is equal to 100 into log x by xi divided by log xs minus xi using this basic fundamental. So this is the linear relation. Now here also at 0 degree centigrade, right, you can use that. So is equal to a log xi, ice point, because it is at the ice point, plus b. If it is a steam point, that is at 100 degree centigrade, is equal to a log xs, thermometer property of a steam, plus b. So this is the equation 1 and this is the equation 2. So equation 2 minus 1, you can get the value of a and you can get the value of b. Once after getting the a and b value, substitute in this particular relation, then you can get the final expression as like this one, right? Hope this particular things are clear to you. So this is one type of a problem on zeroth law of a thermodynamics. There is the another problem last. So this is one problem here. This is another variety of a problem. So in this case, define a new temperature scale. So this is also one of the important problem from this particular cases. So define a new temperature scale. Define a new temperature scale that is degree n, in which the steam and ice points are 400 degree n and 100 degree n respectively, and correlate this with the centigrade scale. The degree n reading on the scale is a certain number of degree on a corresponding absolute temperature. What is this absolute temperature at 0 degree n? So this is how the problem it is to be solved. So you have to draw the two lines. That is one. This is going to correspond to the degree n, right? And there is another line which you can consider here, and this is going to be the degree centigrade. And now you can mention the, because it is at this case it is 400 steam point. So this is the steam point, and here it is 100 degrees centigrade. And the another one is that the ice point, it is at this case it is given as a 100 degree n, 100 degree n, and here it is given as a 0 degree centigrade. Now your aim is this is T degree n, and corresponding to this one, this is T degree centigrade. So this is how you have to correlate this particular scales from this particular point of view. Now coming to this here, and correlate this correlate this with the centigrade scale. So the degree n scale, you have to correlate it with the degree centigrade scale. So how you are going to find out? So this is T degree n, because this is what you need to find, minus ice point. It is 100 divided by the steam point, it is 400 minus ice point, is equal to the thermometric property of substance X, that is required condition, minus X ice. So this is the at the ice point, divided by thermometric property of the substance at the steam point, thermometric property of the substance at the ice point. So with this relation, now you will get it as a T degree n. That T degree n is, you will get it as X minus Xi divided by Xs minus Xi into 100. So that is into 300 plus 100. So this is the equation 1. And the second equation, that is T degree centigrade. So that T degree centigrade is equal to, directly this T degree centigrade divided by 100 is equal to X minus Xi divided by Xs minus Xi. So this is the second value. So from the equations 1 and 2, so from the equations 1 and 2, you can get the value, that is the relation T degree n. Finally, we can get from 1 and 2. You can get the T degree n is equal to, after making the calculation, then 3 T degree centigrade plus 100. That is, this is plus 100. So this is the equation 3. This is the equation 3. So and already we know there is a certain relation, that is the limit Pt tends to 0. Pt tends to 0. That is the Ps, steam point pressure, minus the triple point pressure, is equal to 1.33, 1.366. Sorry, it is 1.367. You can also take it as 1.367, right? And this is nothing but equal to Ts divided by Tt. Ts divided by, that is T ice point, steam point divided by T ice point. So from this particular relation, that is, we know that here Ts is equal to, it is 1.367 Ti. When we know this Ts is equal to 1.367 Ti, then already we know that the difference between the steam point and the ice point from the new temperature scale, that is nothing but equal to 400 minus 100, that is equal to, you can get there's a 300. Then substituting this Ts and Ti with these two relations, you will get the Ti value as, you will get the Ti value as 820 degree N. That is with these two relations. With this two relation, Ti value is 820 degree N, and the steam point value as it is 1120 degree N, 1100 degree N, 1100 degree N. Then from this particular side, then the another relation that the another relation. So what is that here? The capital T degree N absolute. So this is what you need to calculate, the absolute is equal to small t degree N minus 100 plus the ice point, that is this one 820 plus 820, but they have asked this one at 0 degree. So 0 minus 100 plus 820 plus 820. So you will get this particular T degree N value as 720 degree N absolute, 720 degree N absolute, 720 degree N absolute. So this is how you have to make the calculation. Hope for today's class I have covered so many problems onto the zeroth law of a thermodynamics, and the student has to recognize the importance of a zeroth law of a thermodynamics for solving the different varieties of a temperature scales of a problem in this particular connection. And finally, the summing up, applying the basic fundamentals on zeroth law of a thermodynamics to solve the numerical problems for different scales of a temperature. So that is the outcome from this today's class. Outcome from this particular today's class, right? So here you can also do that particular cases for this where directly you can find out, because the pressure of air in the bulb of a constant volume gas thermometer. So that temperature, that T is equal to pressure is P minus P at the ice point divided by steam point ice point. So directly you can make the calculation. What is that? A constant volume gas thermometer, 73 centimeters of mercury at 0 degree centigrade, 100.3 centimeters of mercury at the 100 degree centigrade, 77.8 centimeter mercury at room temperature. So 77.8 at room temperature minus the ice point, it is 73, divided by steam point, it is mercury at that is 100.3 minus 73, and you can get the find the room temperature in degree centigrade value. So directly after solving this numerical problem, you can get the answer. So this completes the all problems connected to the zeroth law of a thermodynamics. Hope all you have enjoyed this particular lecture. That is how to solve the zeroth law of a thermodynamics. Thank you one and all.